Today we shall discuss an interesting thing about L'Hopital's rule, which is often used in evaluating limits. So, first let us quickly check what is L'Hopital's rule. Suppose you have a limit like this: limit x tends to a, fx over gx. So if this limit comes to be of indeterminate form, then this is exactly equal to limit x tends to a derivative of f by derivative of g, f dash x by g dash x. So essentially this is the statement of L'Hopital's rule, that limit x tends to a fx by gx is equal to limit x tends to a f dash x by g dash x. Now here are some assumptions or conditions are there. That first assumption is that f and g are both differentiable in a neighborhood of a, of the point x equals a. This is the first assumption, and the second assumption here is that derivative of g at the point a is non-zero. So if these two conditions are satisfied, then L'Hopital's rule says that this will happen. Okay, now the essential question here is, for evaluating the standard limit sine x by x, so can we use L'Hopital's rule to evaluate limit x tends to 0 sine x by x? So this is the essential question, which is a type of tricky or conceptual question. So let us see what is the problem. So if you check with the conditions given here and with this limit, so essentially sine x is a differentiable function in a neighborhood of 0, and also x is a differentiable function in a neighborhood of 0. So then simply the conditions 1 and 2 are satisfied for this limit. So we can just say that this limit is equal to derivative of the numerator is cos x and derivative of the denominator is 1, and if you put x is equal to 0 here, so it will be 1 over 1 and that equal to 1. So essentially we can say that we can find this limit with the help of L'Hopital's rule, but the fact is that there is a catch, that we cannot do such things. That's why. So essentially it seems that we can evaluate this by L'Hopital's rule, but where is the difficulty? So now here we have to deep dive into the fact that there is a difficulty. There is actually there will be a difficulty, and we have to check what may be the difficulty. Okay, so let us just see. So the first thing is that let us examine this thing closely. So when you are saying that while using L'Hopital's rule, you are using the fact that derivative of this numerator sine x is equal to cos x. So you are using the fact that derivative of the sine x is equal to cos x. So you are using this fact. So I am using the fact. Okay, so I am using the fact while evaluating this limit by L'Hopital's rule. So let us see how this leads to a fallacy. So what is the derivative of sine x by definition? So by definition of derivative, this will be limit h tends to 0 sine of x plus h minus sine x by x plus h minus x. So essentially that is limit h goes to 0 sine of x plus h minus sine x by h. Now here you can see that this is this numerator is of a kind of a thing like sine a minus sine b. So we have a formula for that, that is equal to 2 cos of a plus b by 2 into cos of into sine of a minus b by 2. So that is the formula. So we can write this limit is equal to limit h goes to 0 to cos a plus b means x plus h plus x by 2 sine x plus h minus x by 2 by h. So that will be equal to limit h goes to 0 to cos x plus h by 2 into sine h by 2 by h. Now see that we can write further this as limit h goes to 0 cos of x plus h by 2 into limit h goes to 0 to sine h by 2 by h. So if you see this part is clearly cos x. So we are left with only this part and we have to see what is this part. So remember, we are just getting the derivative of sine x, trying to get. Okay, so for that let us see. So d dx of sine x, actually we started from here and we ended up with this cos, I'm sorry. So this was limit h goes to 0 cos of x plus h by 2 into 2 sine of h by 2 by h. So if we separate these limits of this and this, then we will have limit h goes to 0 cos of x plus h by 2 into limit h goes to 0 2 sine h by 2 by h. So clearly this part, if you set h to 0, this will be cos x, and the second part will be limit h goes to 0 sine h by 2 by h by 2. So here this 2 we are getting this here as h by 2. So essentially we are left with this. Now the problem is that if you consider h by 2 to be a number k, then k goes to 0 as h goes to 0. Then we can write this expression as cos x into limit k goes to 0 sine k by k. So the essential thing is that when you are saying that the derivative of sine x is equal to cos x, then definitely you are making the assumption that this part is equal to 1. That means the limit k goes to 0 sine k by k, this is equal to 1. So this is the assumption you are making when you are saying that the derivative of sine x is cos x. So now I think you are getting my point slightly now. So let us just now check. So when we are applying L'Hopital's rule, on this, what we are doing, we are saying that the derivative of sine x is cos x straight away. But while when we are saying this derivative of sine x is cos x, actually we are making the assumption that limit k goes to 0 sine k by k, that is exactly limit x tends to 0 sine x by x, this is 1. So this is our assumption already we are making when we are saying that the derivative of sine x is cos x. So it's like that you are evaluating limit x tends to 0 sine x by x, you are trying to evaluate, and while in the process you are making the assumption that already making the assumption that the value of this limit is 1. So this is actually, this leads to a fallacy actually. So that's why you cannot use L'Hopital's rule while evaluating this standard limit x tends to 0 sine x by x. Okay, I hope that this